In this video, I'd like to offer some hints while you're working on the activity for this particular day's assignment in class. Essentially, you're using the law of sines or cosines to solve each triangle. And for each problem, there are basically three things that I'm asking you to do. Number one, I want you to identify the case associated with each triangle, 1, 2, 3, or 4. Number two, after you've identified the case associated with the triangle, decide which law is being used to solve that case. Then step number three, I'm asking you to complete solving the triangle. Now you'll notice that in some of the examples there is a letter X that's included in the problem. I'm asking that you ignore that letter X, pretend that it's not there, and go ahead and solve the entire triangle for all side lengths and angle measures. When the letter X is presented, the textbook itself was asking you just to solve for that component, but I'm actually asking you to complete the entire triangle as it would be solved when you completely solve for all side lengths and angle measures. Similarly, if a triangle has an angle measure theta marked, I don't want you just to solve for angle theta, but instead all angle measures within the triangle. You may also notice that there are a set of problems on the left and the right that utilize the same numerical values. So with my answer key that's posted, you'll see that I have a set of answers for the left column and a set of answers that are provided for the right column. Now the answer sheet looks something like this, where I have solutions that are indicated. And you can see that angle measures A, B, and C are provided on the left, while side lengths are provided on the right. These answers are provided for reference only, and I would like to remind you that it's very important during this process for you to show your work while completing your assignment. Leave evidence indicating how you solved for angle measure C or side length B and side length C. Even if you transition from different laws to solve for different components within a problem, that's perfectly fine. Make sure that you show evidence of your work or your method. One thing I would like to note is that at no point in this particular assignment will you be using the Pythagorean equation. Remember, that equation is reserved for right triangles only, and none of these are right triangles. Now, the other thing that I'll point out too is a reminder that in problems 13 through 18 on the left, as well as 13 through 20 on the right, no diagrams are provided. So a good idea would be to use a simple diagram to sketch out the triangle values and then use that to determine your cases. Now, at the very last point of information I'd like to share with you is that number 18 and 19 on the right-hand side, on the right-hand column, proved to be quite interesting. In fact, the angle measures and side lengths that are provided for these problems produce what we call ambiguous cases of oblique triangles. And as it turns out, there may be more than one solution to a triangle with these given pieces of information, or we might note that it's impossible to create a triangle with these pieces of information. So it's entirely possible that when using a calculator to solve your triangle here, you may encounter errors, and we'll show you how to address those errors in the next video. So you should be able to solve everything without any trouble, I think, except for 18 and 19. And if you do encounter any errors or mistakes with 18 and 19, we'll talk about the ambiguous case in the next video. I hope this helps, and again, I highly encourage you to try solving these triangles on your own. If you have any concerns or questions with the work that's being done in this activity, bring that to class so that we can chat about it and I can help you understand them better. Thanks for watching.